Building super apps is becoming very common in large economies like the USA, India, and Southeast Asia, where users expect a single app to handle everything from food delivery and hotel bookings to payments and shopping, and these are called super apps. For example, Uber started with ride hailing and now also offers food delivery like Uber Eats, also groceries, package delivery, and even public transit all in one app. Grab from Southeast Asia combines ride hailing, food delivery, payments, and hotel bookings. Paytm from India includes mobile payments, recharges, bill payments, shopping, insurance, and ticketing. Most of these super apps follow a hub and spokes model, where the main app acts as the hub and each feature like food delivery, groceries, or travel is a spoke connected to it. This allows teams to build each service independently while keeping the overall experience pretty seamless for users. As these super apps grow in complexity, the need for a modular architecture also grow with it. In FlutterFlow, libraries are making this modularity possible, especially with the newly released feature from 6.0, which is Pages and Library feature. Now let's talk a little about the hub and spokes model before we move forward. In this pattern, we separate the application into a central core, the hub, and modular plug and play feature units, the spokes. In our case, we will be using the e-commerce flow project as the hub, and then we have the service libraries like Flow Eats, Flow Mart, Flow Stays, etc. that have completely different user journeys and are independently developed. They are imported into the hub and integrated into the main app flow. So here's the main project or the hub called the e-commerce flow super app. This is very similar to the documentation project e-commerce flow that you constantly see in most of the interactive examples in our documentation. So this serves as an entry point for our users and includes a home page here that displays promotional banners, some coupons, and it also has a bottom navigation bar. Currently has the profile page and has the dashboard or the home page. Since we are building this as a super app, the bottom navigation bar will link to the home pages of individual services like groceries, food delivery, or hotel bookings. Each of these services is built as a separate library project and added to the main project as a library dependency. For example, let me show you. Here we have the Flow Stays library, which is for hotel bookings. And then we also have the Flow Eats library for food delivery, etc. We can also have Flow Mart library for groceries, Flow Ride library for public transport, etc. Each of these service libraries also depend on a shared payments library. For example, it has the logic for choosing a payment method or payment confirmation screen, etc. And even though the payment logic is centralized in one place, each service library will import this payment library so they can access the payment pages and integrate them into their own flows. There's also something called like the Flow Components library, which acts as the design system. It has the shared color theme and other UI components that is shared between all hub and spokes, which means the main app and all the service libraries. I am back on my project dependency page and I will import the Flow Eats library. And let's see what we have. So we have 3 library pages, which is the restaurant homepage, subcategories page, and the cart page, and few other resources like the app states, app action blocks, etc. Great. I'm also going to make sure the version is set to current. So we have all the latest changes that we do in the other library project. Then I'm going to also add the Flow Stays library. And it will have similar like the Stays homepage, the hotel details page, and other resources like data types, components, etc. And I'm also going to set it to current. Now that this is important, let's talk about navigation. One of the key aspects of a super app architecture is how navigation is handled. When you add a library to a FlutterFlow project, all the pages from that library are automatically added to your project's navigator, allowing routing across modules. This means that pages from the Flow Eats library and Flow Stays library or any other service library that you import are now available for use directly within our main project. For example, I have this card here, which is for coupons, and let's say that we are going to navigate to one of the Eats library pages. So let's go to navigation, navigate to, and let's see. Here you can see that these are the pages that are locally available in this project. And then you also have some pages that are available from your libraries that you have imported. For example, the utility functions library also has a page. Then you have the Flow Components library, the Flow Eats library. So let's go to the Flow Eats library's restaurant homepage. So now you are able to navigate to a page that is in your library. Now for apps with a bottom navigation bar. So here if you can see that we do have a bottom navigation bar which currently has the profile and the homepage dashboard. We can also add one of the library pages as a part of this bottom navigation bar. The usual way of adding a page to the nav bar is through the page settings right here. But this is going to be a little different for library pages. For library pages, we are going to go to the project dependencies and open the details for that library. And if you can see, along with the library pages, we have something called the Navbar settings. So here you're going to click on that and see you can show this page on Navbar. And you can add a label if you have labels. So in this case, I say that this is Eats. And then you can add a icon, which something like a restaurant. Right. And you can also add the icon size. And yep, that is now added to your bottom navigation bar. So if you go back to your home page, you will see that there is a new icon added to your bottom nav bar. If you want to change the order of the navbar icons, you can go back to your navbar settings page, and here you can change the order. And if you can see, the library page is now added to this settings as well. Now if I run the app, the navigation works great, and when I go back, the navigation stack behaves exactly as expected without needing any extra logic. You can also pass down some data as page parameters when you're navigating to a library page. For example, we have the Flow Eats library, and let's say that the restaurant homepage has a page parameter called apply promotional discount. So now if I go back to my homepage here, I might want to navigate from this coupon page because I want to enjoy the 20% off. So here I will look for the restaurant homepage. And if you can notice, there is a parameter that you can set here. So in this case, I will say apply promotional discount as true. This will apply this field when we are navigating from this coupons page. However, please note that in this case, if your parameter in your library page is required, but also the default parameter is not given, and you confirm that, you will see that this will throw an error in your navbar settings. So let's see, we will give this some time to apply the changes. And now if you see, there is a new error here which says cannot use page with required page parameters without default values on the navbar. So make sure that when you are creating a page in your library and it has a required parameter, make sure that it is given a default value. All right, so we confirm that, and now we are able to pass down parameters down to a library page as well. So at this point, the main project, which is the e-commerce flow super app or this hub project, has access to all these service libraries like the Flow Eats library, the Flow Stays library, and also the utility libraries like the payment library and the Flow component library. With this approach, you can have different teams working on different library features, and such an approach helps you scale as you grow. Another thing to discuss is the state management between a hub and a spoke. As you create this modular system of interconnected libraries, managing this shared state and data flow between modules become a little bit more critical. Now, the data flow could be cross-functional. For example, parent may need to set some data in a child library, or the child library may need to set some data in the parent library. FlutterFlow provides two approaches for enabling this. We have the app state, and then we also have the library values. Together, they allow both the parent and child libraries to manage and share data without any tight coupling. So you already know that app state variables are always defined inside a FlutterFlow project, whether it be the library project or the main app, and they usually scope to the project that defines them. However, when a library is imported into a FlutterFlow project, let's say this hub app, the hub project now has access to the app state variables of the dependency library project as well. For example, let's see we have this address edit screen, and we have this component that has the confirm location button. And as you see, the address screen is actually on the hub project because it is a screen that is common to all the services. We need to make sure that all the service libraries like the Flow Eats library or the FlowMart library also has the updated address string in their project. So for example, each project has this current delivery address. This is the Flow Eats libraries app state variable. So here on this component, we have this component parameter called onConfirmLocation, which is an action that is executed when this button is clicked or when this address is updated. So we click on this, add an action. Here we update an app state. Now, if you see the fields here, you obviously have the local app state variables that are available in this hub project or parent project. But if you scroll down, you can also see that you have access to the library app state values as well, the app state values of the projects that are dependencies in this project. So in this case, we can set the value for current delivery address, which is set in Flow Eats library. And here you set the value to something like the selected address, which is a paid state in this. So as you can see, the parent can update the values of a child dependency library. However, remember that the reverse is not true. You cannot directly access the app state variables of your parent project, because if I go to my library and go to the dependencies, here I have the Flow Eats library, and if I go to the project dependencies, there is no way I can know who imported this library or who the parent is, right? And this is in fact great because a spoke should be independent of another spoke or its hub. And this will avoid this cyclic dependencies, as that would break the modular architecture. But if I want to set some data of my parent project, here I can go for library values. If you already worked with library values, you already know that there is a way for a library to receive input, data, or callbacks from the parent project, whether that's the main app or maybe another library. These library values are defined in the project. They are used anywhere in the same library project, but the value is provided by the parent project when it imports this library. For example, I can add a simple library value for the Flow Eats one, and I can call it user ID. This is a string, this is non-nullable, and this is part of the Flow Eats library. Let's go back to my e-commerce flow project, and here if you see, there is an error now that I have to set this user ID for this Flow Eats library. So in this case, I just add something like this user ID for now, and this error will be gone. So this is how I can pass down some data from the parent to the library project. But now, if I need to set a parent project's app state, I can use library values to also get that done. For example, here is a app state value called show order status dialog. What does it do? This is going to control a UI component on the homepage, which is super app homepage, and I add component from my components library, which is a order status dialog. Let's move it down, add some padding, and this should be controlled by that boolean variable, which means that I add a conditional here, and this would be show order status dialog. So when this is false, it will disappear, and when this is true, it will appear. Now this is a dialog that says that, hey, there is an order that was placed and here is your current status order. Now it makes sense that this value will actually be set by the service libraries, because only the service library know that there was an order placed, right? So they can tell their parent, which is the home or the hub project, that, hey, there was a new order that was placed. Why don't you show this new dialog which tells the user what the order status is? So now, to ensure that this is set by the child library, in this case the Flow Eats library, we need to make sure that we add this library value in the Flow Eats project, which could be an order placed successfully. So this would be an action and it is nullable. Let's create this. When an order will be placed successfully, let's say when the payment is done, you actually call this action somewhere in the project. And to make sure that the value is provided by the parent, I can go back to the parent project, and now if you see the Flow Eats library, there is a new library value of action type. Here you can provide any app action block. I have not created anything, but let's create a new one, which is show order dialog on success, something like that. It will be an update app state action. So here we have the field, and in this case, we are going to change the value of the app state that is in the parent project. And this is going to set the value to true for now. And this app action block is now assigned on order placed successfully library value of action type. Now you can call this library action value whenever the order is placed successfully, and the value will be changed in the parent project. Okay, so now that we have discovered the power of the library value actions, we can also use it for event action communication between child and parent. Now, what is event action communication? It's sometimes referred to as event-driven programming. It basically means that one part of your application is triggering an event or something happened there, and another part is responding to that action, or basically does something in response to that. For example, you have the payment library and you have the payment confirmation page where we have this button called back to home. It would be great that when this button is clicked, which is the event, the navigation happens back to the home page, which is the response action. Now, that's something that you have been doing in a FlutterFlow project anyway. But now we will be doing the same between different FlutterFlow projects instead. Again, there are two approaches in FlutterFlow for this. One is for the parent to child communication, and then you have the child to parent communication. So let's talk about the first one. So if an event is triggered in the parent project and you want to react with an action from the child library, it's actually pretty simple because you can just use the library's exposed action blocks. For example, if I go back to my e-commerce project and I have this discount coupons to claim, and obviously this is being populated from something, right? The hub project does not have any idea about it. When this component is initialized, so which is an event here, so we have the honest initialization action trigger, we get the restaurant offers from the Eats library, which is in response to it. So we add an action and we search for get discounted restaurants, which is an app action block coming from the Flow Eats library, and we call that. And now we have the list of offers from the Flow Eats library in our home page. So this is pretty straightforward. It's just calling a child library's action blocks. But when there is an event in the child library, for example, I just talked about the payment confirmation screen, which has the navigate button that should go back to the home page when this button is clicked, which is the event part, and the action is the navigation. So this is where we should be using the library actions again. I'm going to show you an example from this Flow Eats library where I have the restaurant homepage, and then you have this header which has an action called on address edit clicked. Now I would love to go to the address edit page which is currently hosted in the hub project. So basically the child will get the click event for this address edit thing, but it will go to a page that is currently hosted in the parent project. So let's see, we have the on address edit clicked, which needs to be an action, but let's create that action first as a library value. And here we create a value called navigate to edit address page, which will be an action. It will be non-nullable. We create that. Now this action can now be called from this on address edit clicked. So we just search, we just find it here, navigate to edit address page. So at this point, the logic is still not provided. So if you run this and you click on the edit address component, there is nothing to be executed here because this value is going to come from the parent. So let's close this and go back to our parent project, and I can go back to my project dependencies. All right, so we do have the navigate to edit address page library value added now, and it needs an action block, an app action block. Let's create an app action block called navigate to edit address. Let's create that. We add a navigate to action, and it will be the address edit page. And now this action block, which is set and defined in the parent project, is now assigned to the child library's library action value. So every time this element from the child project is being clicked, we are navigating to a page in the parent project. So this is the other way where a child can trigger behavior on the parent side without ever knowing who the parent is. Now, just to get it clear, when to use a library action block versus library value of action type. Well, if a library wants to tell the parent something happened, like an order being placed, so the parent can act on it, then a library value of action type is your go-to choice. If a parent wants to trigger something in the library, something like trigger payment, then library action block is your go-to choice. Now, those are some of the approaches you could take while building either a super app or any kind of app where you want to break down the features into modules so you can work on them in isolation. FlutterFlow's library system allows you to encapsulate feature modules like this, like food delivery or a hotel booking, into isolated projects with their own owners if required. It also helps you share reusable logic with the utility libraries like payment or UI component library. It also helps to manage data flow and state management through various approaches that we discussed today. More importantly, for Flutter devs who have an existing Flutter project, you can just build one of those features in a FlutterFlow library and download the code and add it as a dependency to your existing project. This way, while you apply patterns like the hub and spokes, you can keep your code base more modular. Let us know in the comments below if you are building a production app and if you'd consider going the modular way instead of having everything in the same FlutterFlow project. See you next time and happy building.